going to do, just for these next two, we're going to make a chart because I just want us to remember. The number next to sine can be usually in degrees or radians. We're going to do it in degrees because that's the way your homework is tonight. So we're going to do 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And I want you to recall your good old unit circle. Here's 0, which is the point 10. Here's 90 degrees, which is the point 01. 180. And then down here is 270, which is the point 0 and -1. So if you were to graph the sine at 0, here's 0 degrees, which one of those two numbers would be my answer? 0. The sine at 0 is 0. What's the sine, though, at 90? Which one of those? 1. What's the sine at 180? Back to 0. What's the sine at 270? -1. And then a full circle would be 0. Notice the repetition, 0, 1, 0, -1, 0, 1. They're circular. It's a circular function.
Could you repeat that? How did you find the y?
How did I find the y? Remember, this is your cosine. This is your sine on a unit circle. This is your cosine. This is your sine. So if I said,
Just go around
right, okay. So if I'm graphing this, if you notice, my numbers only go as high as 1 and as low as -1. I'm going to graph 90, 180, 270, and 360. I'm going to go plot these points. So sine at 0 is 0. Sine at 90 is 1. Sine at 180 is 0. Sine at 270 is -1. And the sine at 360 is 0. This right here, what looks like a sideways S, is actually one cycle of sine. One cycle of sine. You need to look at these one cycles and almost kind of memorize them in your head. One cycle in mathematics is called a period. We learned about period. Remember, on the last quiz, I gave you a bunch of different graphs and I said, where's the period? Where is that one cycle located at? So the one cycle of the graph for us right here would be 360 degrees or 2 pi if I was talking about radians. That would be one cycle of sine. And then it would keep repeating every 360. So at 720, you'd have another cycle of sine and another cycle of sine. The amplitude refers to the absolute value of half the distance between the max and min values. The absolute value of half the distance between the max and min values. So if my max is 1 and my min is -1, and I take that distance, that's a distance of 2. Would you all agree, right? But take half of that distance. What's half of that distance? 1. This has an amplitude of 1. So sine graphs almost always have a period of 360 and then an amplitude of 1, unless we change this number next to x or a number outside of x, which you'll find out when you do your homework tonight. So there's sine. Very easy. Let's do cosine. And let's do a chart for this one too. 0, 90, 180. You do not have to make charts tonight. You're just going to be doing it in the calculator, but I'm trying to show you where this is all derived from. So what is the...
What about you think like the vinyl tablecloth?
All right, so cosine, there it goes. So notice again, cosine at 0 would be which one of these then? 1. The cosine at 90, though, would be the x value, which is 0. At 180, it's -1. 270 is 0, and then back to 1 again. So when we graph this one, again, we're only going as high as 1 and -1. So cosine at 0, here's 90, 180, 270, and 360. Cosine at 0 is 1. So you put a dot up here. At 90 degrees, it's 0. At 180, it's -1. Then 270, then 360. And by the way, when you go to draw your cosine graph, you kind of make a little curve because it continues to go. We're just only drawing the one cycle of it. Again, this is one cycle of cosine. Its period would still be 360 because this is one cycle, or 2 pi. Its amplitude, what would half the distance from the max and min be here?
0.
Try again. Half of the distance from the max to the min. The distance from max to min is 2. Half of that is 1. Okay?
Isn't the same as the height?
Exactly. It's pretty much the height. All right. 3, tangent. So tangent is different. So here's what happens to tangent. Tan is your, we talked about this before, your what over your what?
Sin over cos.
Sine over cosine. So if I go up here to my unit circle, at 0 degrees, I put 0 over 1. Is that allowed? Is 0 over 1 okay?
Yeah.
Yes. Is 1 over 0 allowed? No. So at 90 degrees and 270 degrees, I am undefined by tan, which means on a graph, I have at 90 degrees right here an asymptote. 180 and then 270. Also, there's another asymptote. Okay? Your tan graph looks like this. It actually almost looks like the cubic function. You would see, by the way, another piece of the graph right here and another piece of the graph, like if you were doing 360, you would see that. But really, your one cycle of tan is right here. This is one cycle of tan. What would be that period? What's that period right there? From 90 to 270, that is one cycle right there. What was 90 to 270? What degree is that? 180. So for tan, your period is 180 degrees or pi. Your amplitude, half the distance from the max to the min, well, what's happening here? Infinity or none. You can, it depends on your book. I'm going to say none because that's what ours says, but you can say, I've seen books say infinity also is the amplitude. Okay, so there are your first 3 pictures. We're going to do our last 3. We're going to do cosecant, secant, and cotangent, and then we'll graph and we're done. And I'll show you how to put it in your calculator. Super, super simple stuff today. All right, so number 4 is y equals cosecant x. What is cosecant really? It's the reciprocal of what?
Sine.
Sine. You cannot type cosecant into here. You would have to type y equals 1 over sine x. So just remember that tonight. You have to type 1 over sine. So here's what I want you to do when you go to graph it. It's really easy. You actually graph the sine curve. You go as high as 1, as low as -1. You make 4 marks. This is your 90, this is your 360. Oops. And your sine curve looks like this. It starts right here in the middle. At 90, it goes up, goes back to the middle, down, and up. And just kind of dash it in. Here's what cosecant does. These bumps right up here, it actually makes what almost like a parabola looking thing. This one up here, and then this one down here. There are asymptotes right here and right here, which is at 180 and 360. Why are there asymptotes there? Again, if you're thinking about the unit circle, let's just go to 360, which is 0 right here. Your point right here would be 1, 0, right? If I said reciprocate sine, what's the reciprocal of 0? A reciprocal to 0 is undefined. The reciprocal of undefined is 0. So that's why there's asymptotes right here and here. What you've just drawn, when you have one up and one down, that is one cycle of cosecant. An up and a down, one cycle. Up, down, one cycle, okay? One cycle of cosecant. The period, an up and a down, the period is 360. Again, or 2 pi. Your amplitude, how high is half the distance from the max to the min? Well, if they're looking like parabolas, how high is it going? How low is it going? Infinity again or none? Has no amplitude. Moving on, number 5. Secant x. Yes, Liam?
What was the amplitude of interval 3?
None. Secant, what's its reciprocal? So 1 over cosine would be what you would have to type into your calculator. Again, draw one cycle of cosine. This is how my teacher used to teach us how to draw it. That's why. So you go start at 1, make 4 dot, 1, 2, 3, 4 dashes, and then you go down, down, up, up. That is the cosine. The reciprocal would look like this. You would have half of a hook, an upside down parabola, and then the other half. That is one cycle of secant. Again, why is there, asymptotes happening? Because you're trying to reciprocate zeros. And you can't, the reciprocal of 0 is an undefined asymptote. So what's its period? Again, a half, a full down, another half, that is 360. This is 360 right here. So 360 is the period. The amplitude is none. It goes off. And last but not least, cotangent. What's the reciprocal of cotangent? Good old Mr. Tan. Okay, so here's what happens with tangent. So if you remember over here, if you look at tangent, see how it curves up that way? It has asymptotes at 90 and 270. Cotangent actually has an asymptote at 180. The asymptotes shift over. And the graph doesn't start at the bottom and go up. It actually starts up and goes down. It flips that way. Okay, and it goes through at 90 degrees. And its period is similar to tangent. It has a period of 180 degrees, or pi. Its amplitude is none. So the only things that can have amplitude, really, are sine and cosine. That's it. Everything else doesn't have an amplitude. All right, so now, if you take out your little packet for me, we're going to do 1 and 6 together. I'm going to show you how to plug it in your calculator. So I want to make sure everybody's calculator is working. So please, 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 if you have a problem with your calculator, let me know. Good question. This whole entire worksheet is in degrees. Do you see how everything's in degrees? Tomorrow will be in radians because I want you to know both ways. Make sure your calculator right now is in degree. If you don't know how to go there, hit mode, arrow over to degree. Okay. So go to, by the way, they're using theta for everything. That's not a 0, that's a theta. You could call it x. I actually am going to call it x. So go to y equals, and you're going to type in 2 cosine x, 2 cosine x, and close the parenthesis. Now, this worksheet is really nice. They actually have given you the window. So you're going to go to window right now, and you're going to read with me and figure out what this is. What is your X min in this picture? What is the minimum value? No, what's your minimum? 0 is your X min. What's your X axis max?
360.
What is the scale that you're going up by? No, what are we going up? 90, 90, 90. We're going up by 90s for the X axis. Now look at the Y. What's your Y min?
-1. 2.
-2 is my Y min. What's my Y max? 2. What scale are they going up by on the Y axis?
1.
They're going by 0.5s actually. You could do 1, but I'm just showing you. I'm just trying to give you what they gave me. Now, when you hit graph, it is actually giving you this exact image right there. It should be. Wow. So this right here is 90 degrees. This is starting at, again, half, 1, 1.5, 2. It's starting up here. Then 180, it's going down to -2. Back up, back up. And you just kind of follow the pattern. There you go. There you've just drawn it. But you have to find the amplitude and the period. What's my amplitude? 2. It is half the distance from the low to the high. There's a distance of 4, so that would be half of it would be 2. What's the period? Do you see one full cycle of cosine right now?
Yeah.
Yes, so the period is 360. Guys, by the way, this is what they ask on SATs and ACTs. These are those last trig questions. They always ask amplitude and a period question. It'll be a little bit more challenging than this. I'll show you how to do those tomorrow or Wednesday, excuse me. All right, so that was an easy one. Let's do number 6 though, harder one, and then we're done. Again, cosecant is not in your calculator. What's the reciprocal though? 1 over sine 3x, not 30, 3x, okay? So you're gonna type in clear 1 divided by sine 3x. By the way, did anybody's calculator mess up just then? Good, great. We're gonna change our window to this scale. So my X min is 0. My X max is not 360. What's my X max here, y'all? 180, right. What am I going up by? 30s. My Y min is -4. My Y max is 4. I'm not going up by halves. I'm going up by 1s. I just am looking at this scale right here. Going up by 1, -1. Hit graph. And this is the picture you should get. And again, how are you reading this? So at the point 30, I have a low number of 1. I plot that point 1. And I draw a parabola, but there is an asymptote right here at 60. You can draw the asymptote in if you want to. And then down here, you would have another asymptote. And it would go up to -1. And then here, there's another one. Whoops. Now here's my question to you. What is the period? Well, actually, let's do the amplitude first because that's easy. What's the amplitude? How high is it going? What's half the distance? None. What is the period? So cosecant, let me take out your things right here. I just gave you. Cosecant, to be one cycle of cosecant, you have to have an up and a down. An up and a down. They've tricked you here. They've given you an up, down, up. But you just need an up and a down. An up and a down. So from here to here, right there is your period. What's that width right there? 120. Where are they getting this from? Well, this is what we're going to learn tomorrow, but I'll give you the hint. The number in front of x you divide it by, if it's cosine or sine or cosecant or secant, you divide that number by 360. Since 360 is one period, 360 divided by that number 3 is 120. And that's what you have to do. This number in front is your amplitude. Always. That's your amplitude. That's your amplitude. Well, except for tan, obviously, because tan doesn't have an amplitude. Neither does secant. But the number, though, next to the x, you just divide it by 360. That's it. So all you have to do is just put this in your calculator. You're done. 1 through 9. That's homework tonight. And I did 2 of them for you. So you have 7 whopping problems. Put them in your calculator. You can do it.